Please like and share my videos and subscribe my channel if you have not already subscribed. Thank you. In this video, we discuss question number 68, 69 and 70 from the paper, from the question paper TS set 2023 October on the topic complex analysis. And this discussion of these three questions is suitable for the aspirants of JL, DL, AP set and CSIR net. We now discuss question number 68 with the question ID given here. The given question is, if f of z is equal to uxy plus iv of xy, iv of x comma y is analytic in an open connected set omega and au plus bv plus c is equal to 0 for some constants a, b, c, then the integral taken round mod z is equal to 1, that is the unit circle of f of z by z square with respect to z is equal to. We are given four options. Right. We have fz is equal to u of x comma y plus iv of x comma y, and it is given to be analytic in an open connected set omega. Agreed. And given this uv are connected by this equation au plus bv plus c is equal to 0 for some constants a, b, c in omega, that is u and v, for all ordered pairs x comma y coming from the omega. Right. Now required to find the integral taken round the unit circle mod z is equal to 1 of fz by z square dz is equal to 2 pi I times f prime 0. We are using Cauchy's integral formula for first derivative. Agreed. Agreed. And we take that the unit circle is entirely contained in the omega. Yeah, this condition should have been given in the hypothesis of this paper, but it has not given, but we have taken like that. Right. Now the question is, what is f prime 0? What is f prime 0? So we have au plus bv plus c is equal to 0. Differentiate partially with respect to x, then ux means dou u by dou x plus bvx is equal to 0. And differentiate partially with respect to y, you will get auy plus bvy is equal to 0. Now fz is an analytic function in omega. Therefore, the Cauchy-Riemann equations are valid in omega. So, the Cauchy-Riemann equations are ux is equal to vy and uy is equal to minus vx. Take these relations, these equations, and put it in the second equation. Then the second equation becomes avx plus bux is equal to 0. So, we got two equations, two unknowns, and we solve. On solving, we get a square plus b square in brackets ux is equal to 0 and a square plus b square vx is equal to 0. And this will imply ux is equal to 0, vx is equal to 0, provided a square plus b square not equal to 0. That means at least one of these a, b is not 0, then a square plus b square is not 0. And this condition also should have been given in the question. That is, for some constants a, b, they said, but this condition is that at least one of these AB is not 0. Then thereby a square plus b square is not 0, and thereby ux is equal to 0 and vx is equal to 0. Right. So ux is equal to 0, vx is equal to 0 in omega. So that means ux at 0 comma 0 is 0 for all points of omega. So and vx at 0 comma 0 is 0. And what is f prime 0? F prime 0 is ux at 0 comma 0 plus ivx at 0 comma 0. And mind you, this 0 is the complex number 0 or the real number 0, that is z minus 0 whole square. So that is the 0, and these are the ordered pairs. These are the ordered pairs. So f prime 0 is ux at 0 comma 0 plus ivx at 0 comma 0, and each is 0. Therefore f prime 0 is 0. So go back to this integral taken round. Mod z is equal to 1 fz by z squared dz is equal to 2 pi I into f prime 0, and f prime 0 comes out to be 0, that is equal to 0. So therefore the answer to this question is 0. That appears against option 4. Therefore the answer is option 4. That is the detailed discussion of the solution of this problem, and we move on to the next question. Question number 69 with this ID. The given question is the number of analytic functions f in a neighborhood of origin and for which f at 1 by n plus f double prime at 1 by n is 0 for all n belongs to the set of natural numbers is, we are given 4 options. So we have to find out how many analytic functions f in a neighborhood of origin for which this is satisfied. How many functions, such functions? 0 function, no functions at all, 1 function, 2 function, infinitely many functions. Now let's now discuss the solution of the problem in detail. We are given f is analytic function in a neighborhood D of the origin. Some neighborhood of the origin, maybe epsilon neighborhood of the origin or delta neighborhood of the origin, whatever. So and also f plus f double prime is analytic on D and vanishes on x is equal to 1 by n, n belongs to n. Now f is analytic in D, then all its, when f is analytic, all its derivatives are also analytic. Therefore f double prime is also analytic. And the sum of two analytic functions is again analytic. Therefore f plus f double prime is analytic on D, and it is given that it vanishes at the set x, that is equal to 1 by n, n belongs to n. That means for all n belongs to n, this is satisfied. That's what is given to us. Agreed. Let capital F of z be f of z plus f double prime z. Let us take a new function, capital F of z, and g of z is the 0 function. G of z is 0 function for all z. Right? So this g for all z belongs to the domain D. This is not g of z, this is D. For all z belongs to D. So it is a 0 function in the domain D, and f of z, capital F of z is f of z plus f double prime z for all z belongs to the domain D. So we have two functions, capital F of z, capital G of z, and capital F of z is analytic, G of z is analytic in the domain D. So let us recall a theorem called identity theorem. So they are analytic in the domain D, and there is a sequence Zn. For us the sequence Zn is 1 by n. So now f of z and g of z are analytic in D, and we have the sequence Zn where Zn is equal to 1 by n and has a limit point 0 in D. So suppose Zn is a sequence of points having a limit point in the domain D. So This is a sequence, has a limit point 0 in D. Then by the identity theorem, so f of Zn is equal to g of Zn. How? This condition should be satisfied. F of Zn is f of 1 by n plus f double prime of 1 by n. G of Zn is 0 because g is a 0 function. So this is equal to 0. So that means this is true for all n belongs to n. Then by the identity theorem, f of z is identically equal to g of z for all z belongs to D. That means what is capital F of z? Small f of z plus f double prime z is equal to g of z is a 0 function. So for all z belongs to D. So what is this? For all z belongs to D, this is the one. It is a second order linear differential equation, homogeneous linear differential equation, and whose general solution we know. The general solution for this differential equation is f of z is equal to a cos z plus b sin z, where a and b are arbitrary constants. Since a and b are arbitrary constants, how many such functions will be there? There will be infinitely many such functions f of z, which satisfies the conditions of the given question. So thus there are infinitely many analytic functions satisfying the conditions given in the question. Right. So therefore our answer to this question is there are infinitely many analytic functions. Therefore infinite number of functions will be there. That is the answer is option 4. Option 4. So that is the detailed discussion of the solution of this problem. Right. Let's move to the next question. That is question number 70 with this given ID. Right. Now, the radius of convergence of Taylor's series of f of z is equal to 1 by z to the power of 4 plus 5z square plus 4 about the point z0 is equal to 1 plus I is. So we are given a function and its Taylor series about the point z0 is equal to 1 plus I. For that Taylor series, what is the radius of convergence? What is the radius of convergence of the Taylor series of this function about this point z0 is equal to 1 plus I? We are given 4 options. Right. Now, solution. Let us recall a result. The result is if R is the radius of convergence of the Taylor series of fz about the point z0, then the radius of convergence capital R is given by the distance between z0 and the nearest singularity of fz. That means catch hold of all the singularities of fz and measure their distance from z0 to those singularities and find out the minimum. Nearest means minimum you have to find out. That will be capital R. Right. So we have f of z, that is 1 by z to the power of 4 plus 5z square plus 4, and that is equal to 1 by z square plus 1 into z square plus 4. And we have its Taylor's expansion about z0 is equal to 1 plus I. Don't worry about it and don't go for the Taylor's expansion. So we have the Taylor's expansion, that much is sufficient. And f of z is analytic everywhere except at z square plus 1 is equal to 0 and z square plus 4 is equal to 0. That means these are the singularities. These are actually the poles. What are the poles? The poles are z is equal to plus or minus I and z is equal to plus or minus 2I are the poles. So how many singularities are there? 4 singularities are there. Now capital R is the minimum of the distance of z0. Z0 is what? Z0 is 1 plus I to z. Z belongs to the singularities plus or minus I plus or minus 2I. So 4 distances you will have. The distance between z0 is 1 plus I. 1 plus I to I, 1 plus I to minus I, 1 plus I to 2I, 1 plus I to minus 2I. And very easily you will find the distance between 1 plus I to I will be minimum, or the distance between 1 plus I to minus I is also the same answer you will get. That is the distance of 1 plus I to I, that is 1. And the distance between 1 plus I to 2I is greater than 1. So you have to take the minimum. So that is the 1. So the radius of convergence of the given function, the radius of convergence of the Taylor series of the given function about z0 is equal to 1 plus I is 1. So the 1 appears against option 3. Therefore, the answer to this question is option 3. And that is the detailed discussion of those 3 problems which we wanted to get in for this video. I am sure that you have understood the solutions of these 3 problems, and I make a request that please like, share my videos and subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.